All right, so in this video, we'll just discuss what we've already gone over in class, and that's the different triangle congruence criteria and when they can be applied and how they look. So this first part is actually what we just did, what we wrote in class on that guided practice. We'll just go through it real quickly here. Like one, what are or which criteria have been established to prove that two triangles are congruent? We can say side, side, side. Side, angle, side, angle, side, angle, 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 side, and then the last one is hypotenuse leg. And we're saying that a hypotenuse leg is angle side, side, given that the side 2 is greater than side 1. Or those are two cases. You can use it angle side side if side 2 is greater than side 1, or if we're dealing with a right triangle. We'll show that here below. Then which criteria do not establish congruent triangles? Well, 3 sides do, but 3 angles don't. 2 angles don't, and 1 angle doesn't. 3 sides can show triangle congruence, but 2 sides won't, and neither will 1. And then the last one, right, we've got side, side, angle. Doesn't work. It doesn't work for all triangles anyway. There's some certain cases that it does, and that's what we're going to just do down here. First case is when that side 2 is greater than side 1. So the idea being, we have an angle. We have side 1. If side 2 is longer than side 1, side 2 is longer than side 1, then it's guaranteed that there's only one triangle that's possible. Only one triangle is formed. So if you have the condition that two triangles have corresponding angles, side 1 and side 2, if side 2 is longer than side 1, then it's guaranteed those two triangles are congruent. Okay, case 2. This is the case where we have an angle, a side, and a side 2 that just happens to be too short. Right? In this case, we're not going to see because it doesn't even form a triangle, so no triangle is even formed in the case where the second side is too short. Okay, the third case where you see angle side side is when side 2 is shorter than or less than side 1, but there's one point of intersection. Okay, so that's going to look like this, where we have an angle, we have side 1, and then side 2 is going to meet this third side in only one place. And it can only do that if it intersects or meets it at a right angle. Okay, so if this is the case, where side 2 is less than side 1, but it meets it at one point, well, that forms a right triangle. And in this case, one point of intersection means only one triangle can be formed. And since we're dealing with the angle side side, and for a right triangle, that means that any two triangles that share that corresponding information will be congruent, then instead of saying angle side side for a right triangle, we just use the abbreviation HL. So it's the HL case, which stands for hypotenuse leg. Okay, and then our last case. This is that swinging leg case where we have an angle, side 1, and in this case, side 2 is going to be shorter than side 1. But we could swing or pivot at that vertex. And if we swing or pivot at that vertex, we're going to end up with 2 points of intersection, or 2 points of possible intersection. One here, or one here. So side 2 can intersect the third leg in 2 different places. So this is, we're going to say the swinging leg case. And in this case, 2 possible triangles are formed. Okay, so what that means is, if that's the information you're given, you can't determine if the two triangles are congruent with just that information, because one could be this obtuse triangle, and then one could be this acute triangle. So the two that work, okay, the two that are good, case number 3, if that's the information you're given, only one triangle is formed, therefore two triangles with that same information have to be the same, have to be congruent. And then case number 1, you need two triangles with that information, have to be congruent. All right, next, we're just going to write these theorems out in words. Okay, so we're dealing with the side-angle-side congruence theorem, and it just says if two sides in the included angle, now we've talked about it, we haven't defined it, or at least written a definition. Included means the angle between the two sides. So if two sides in an included angle of triangles are congruent to the two sides included angle of another triangle, then those two triangles have to be congruent. I'll try to abbreviate when I can. Okay, we'll just do a quick drawing. So that means we have two triangles. The side angle side case means that we're dealing with a side, a corresponding angle, or two sides in an included angle on one, and the corresponding two sides in an included angle on the other. Okay, so side angle side is going to look like this. All right, side, side, side. This time it says if three sides of one triangle are congruent to three sides of another, then those two triangles are going to be congruent. And again, you're going to see diagrams where the two triangles are going to be marked with three pairs of corresponding sides. All right, if that's all the information you're given, then those two triangles have to be congruent. Okay, the hypotenuse leg congruence theorem only works for right triangles. Okay, this is the SSA criteria. And the idea is if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Okay, so we're dealing with a right triangle or two right triangles, corresponding legs and corresponding hypotenuses. We'll call it that. All right, angle side angle. If two angles in the included side of one triangle are congruent to two angles in the included side of another, then the two triangles are congruent. Okay, so we have two angles. Remember, the included side has to be the side that's in between the two angles. With that information, the two triangles are forced to be congruent. All right, and then our last theorem. If two angles and a non-included side of one are congruent to two angles, and the corresponding, means in the same position, non-included side of another, then the two triangles are going to be congruent. Okay, so two angles and a non-included side. Angle, angle, side. All right, we'll just do a couple practice problems. A couple we do, you do. This is just stating whether or not the triangles are congruent with the given information. right? So you're just looking at the diagram, based on the diagram, and these are pretty easy, easier than the ones we did in class. Now everything has to be in corresponding with another, like this side is between the two angles, so it has to be in between the two angles on the other. So we have angle, side, angle. Yes, those two are congruent. Angle, side, angle. B, the angle is between the two sides. This angle is between the two corresponding sides. So we've got side, angle, side. Okay, so you have these three to do down here on the bottom, and then you have this one to do on the right side. We'll do this one together. What additional information is needed to prove the two triangles congruent using the given theorem? Then write a congruent statement. This is just like the entry task we did. If we're using the side theorem, the third piece of information would have to be that EL and KA are congruent. So we can finish this off with side, side, side. And we can say triangle. Doesn't matter the order we start with, CEL. We just have to have the corresponding order on the second triangle. Triangle KA. All right, so what piece of information is needed to use ASA and then write a congruent statement? All right, I'm under 12 minutes. All right, so hopefully that wasn't too bad. No questions here at the end.